This is a new year with new challenges. Oh! Every single day, we feel this weight on our shoulders to maintain our team's legacy.
We're not building some small-scale prototype. We're actually building something that, we have to protect the life of the driver, and, there's some seriousness in the work that we do.
We face a lot of setbacks during manufacturing. A lot of what we imagine the car to be like is not what it is in real life.
If something isn't up to standard, you have to go back and fix it. But if it's not fixable, then you're kind of screwed.
We don't know how far we're going to get into comp, so it's very nerve-wracking. Everything's uncertain right now.
The thing that's different from this year is that we're switching to a new motor, we're getting a new battery pack, we're adding the first aero package, so we have to be confident in our design, but even if we're confident in our design, we have to be ready to expect, maybe it will fail. So we just need to, be confident in ourselves, get it manufactured, and test it. But overall, I think this year we're taking big leaps, and I think in the end, it'll be worth it.
So FRUCD stands for Formula Racing at UC Davis. Our main goal is to design, build, and race a fully electric Formula-style race car. So the history of Formula Racing is that it was established in 1998 as just an SAE team. And then it wasn't until 2012 that we moved on to fully electric, to the electric category of FSAE. And since then, we've been building a electric race car for 12 years. So now we're on FE12, building our 12th ever electric race car. We're currently standing at about 150 members. We're definitely one of the biggest engineering clubs on campus. Formula Racing is split into 5 different departments: structures, unsprung, powertrain, electrical, operations, and then each of those departments are split into a few others. So if I were to describe project manager role in one sentence, it would be to get things done. My role really is to make sure that the team has all the resources they need, and then also keep up with the team to make sure that they're doing the things that they need to do on time so that we have an actual running competitive car by the time we get to Michigan this year. So yeah, this is my first year being project manager. It's definitely been an exciting and adventurous role. Especially project manager, a lot of responsibilities and consequences sort of fall on my shoulders. But that's something I've been willing to take, and the team is always supportive of those decisions. I stress about this club every day, every waking hour of the day, making sure everyone has what they need to get their things done.
Heather is our PM and I'm the chief engineer, and as my first year as the chief engineer, I have a lot to learn. It's a lot of just learning and just being willing to ask if I just don't understand, because there's just so many different small little components that go into the car. Somebody has to design this small thing, and being in this position, I kind of have to know at least the general idea of everything that's going on. For next year, I'm really able to get my hands on and make sure that we're making good design decisions and have good goals for the overall car, so we're able to optimize our performance for next year. And then for manufacturing, we have Adbe as the lead.
We basically make sure that the car is being built on time, how it is being built, and do quality control on the parts. We've made a lot of improvements, especially in the manufacturing space. We've been able to greatly reduce the time required to make parts as well as improve the quality. We spent a bunch of money in new and expensive tooling and machinery. We're pretty prone to setbacks, usually with breaking parts and tools, which is pretty common. The solution is to just learn from our mistakes, make sure that we don't repeat the same thing again. And it's a lot of buying new tools and new stock.
I feel that this season is something I'm really excited for. I especially believe the team is working really well together. I feel really excited and I feel very optimistic that our team will do really well this year.
So pretty much what we do in chassis, we're pretty much in charge of designing and fabricating the chassis or the structure of the car. So the chassis is made out of mild steel, which is a little different from what we have done in the past.
So what we do is we design a steel tube structure that, you know, all the other components of the car have to attach to in order for it to run. When we finish our design and we're ready to start manufacturing, we have a sponsor that laser notches the tubes the way they're supposed to be in CAD. So all of our manufacturing is done in-house. And that involves sorts of coordination with all the other sub-teams to package all of their components onto the car.
To manufacture the chassis, we do use a lot of like different machines. We usually use a lot of like hand tools, like die grinders, drills.
Once we get all the tubes prepped and profiled with the notches so that they fit well, we clamp them in the jig, and then we're able to sort of just set the welding machine up and weld it together. That's like the last part of the process. And then we have a pretty complicated jig that we set up on our welding table to like hold all the tubes together while we weld them.
For welding, we use TIG welding, pretty much to weld the whole chassis. I think like TIG welding, it's a lot more precise, and it just looks a lot better at the end of, like, once you finish the chassis.
The most important thing we can do for the rest of the team is finish on time. We were lucky we got the tubes back really quickly this year, so we were able to get a lot done the week after fall quarter ended. In terms of overall performance for the car, I think it's going to be exciting.
We do a lot of conceptual work, like simulating like specific geometries in order to make like aerodynamics very efficient. We design, simulate, and then validate, and that's basically what we do. I think any step forward for Aero is a big step forward. Something big that we're doing this year is designing the first complete Aero kit. Having a base design that works well and gets the job done is really what we're aiming for.
Our team is sort of the bridge between the very abstract work that the Aero team does in like aerodynamic design, and then we translate their simulations and data gathering and all of that into actual components that we can put on the car.
Specifically, we do all of our carbon fiber layups. We manufacture the floors of the car, the front panel, the nose cone, and this year the wings.
We first design a mold for the part, which has the shape of the wing, each half. Then we use a machine called a CNC router, which carves out that shape, and we process the mold so it's nice and smooth. And then we alternate layers of carbon fiber and resin together so that we create a really strong but lightweight part. And then once that part is done curing, we post-process it, just trim the edges, glue them together, and you have your wing. So carbon fiber is a really unique material in that it is incredibly lightweight, but also incredibly strong. And so, if we were to build these parts out of fiberglass or, even wood, other, older traditional materials, that would cost us a lot of weight, which also costs us lap time. And so our goal is to maximize the performance of the car, and by doing that, by using really lightweight advanced materials like carbon fiber, we can achieve our goal of having the best performing car.
Composites is pretty hazardous work. We're sanding carbon fiber, cutting fiberglass. All of those things are really dangerous. So we really try our best to prioritize safety when working. Wearing respirators, wearing PPE, always wearing gloves. It is dangerous, but we do what we can to stay safe. We're still doing manufacturing at Inventopia, which is our sponsor for about 5 or 6 years. They give us a space, to do all of our work, store our things, let our carbon fiber cure, and then we bring it over here to the ASDC once those parts are finished.
Our wings are adding downforce, which enhances the tire's grip when the car is moving at high speed. And so we're hoping that this will allow us to make turns at higher speeds and ultimately be a faster car.
Adding that aero package, hopefully we can get a lot of performance out of it, maybe 5 to 10% faster. Other than that, just maintaining the kind of good look and good performance that we've had before.
Our sub-team suspension connects the wheels to the cars. We're responsible for all the tire characteristics as well as making sure that everything stays attached and the car stays, not on the ground.
The goal of suspension is to maximize tire grip, at all times. Whether that's through turns or straightaways, we have to have some type of combination where we can maximize the tire grip through a lap. Whenever we go to design, we set certain parameters, then we kind of take those parameters and make a geometric model of it in CAD, and then we take that model in CAD and make it into real life.
We go through design, making sure everything fits, everything works, nothing interfered, nothing breaks. And then after that, manufacturing, and then testing and validation, where we go back, we look at those goals and we say, okay, did we hit the goals that we wanted to hit? And if not, because nothing's perfect, we check how much we're off, and we check, okay, what we would do better next time, is the good goal to choose, or the better goals. Suspension is something where if you're off by, a few hundredths of an inch, then, the car, the tires are pointed the wrong direction, things are angled, the car doesn't steer straight, stuff like that. So we focus mostly on being very simple, very robust, and we keep a lot of our manufacturing standard. We don't deviate that much. We're a very critical sub-team. If suspension doesn't work, nothing else works. The car just doesn't run, no matter everything else.
Wheel package is just concerned with everything around the wheels. So that means the brake rotors, the spindles and wheel hubs, and even the attachment points for the suspension. So we're essentially the communicating lines between the main chassis and the wheels. So after we get our wheels, we start defining our parameters, like how much force do we are gonna experience, what kind of things does suspension want, how much clearance do we need to turn the car, etc. And then we start building up from those requirements. So we usually start with the spindles first, and then after that we go into our uprights, and then to our brakes, and so on and so on. So it just builds on top of each other.
I'm in charge of the pedals, so the accelerator pedal and the brake pedal, and I'm in charge of the steering system as well. Manufacturing, we mostly use water jet. We use a lot of the mill and lathe operations to drill holes and to size down rods or anything like that to fit into the system. I would say for the steering system, our main setback is mostly just getting the alignment proper, fitting it in accordance to suspension sub-team for them to align their A-arms and push rods and everything. I also work a lot with the uprights and wheel package to place the tie rods and basically just to get the proper vehicle dynamics to make it run properly. For pedal box, I would say there's not many setbacks. We're mostly focused on weight reduction right now. Most of it is pretty optimized, so yeah, we're pretty good on that regard.
For vehicle dynamics, we develop simulations for analyzing the car, especially optimizing various parameters. Parameters as in just overall design, such as how long the car is, how wide the car is. There's a lot of research that goes into the simulations that we use, And we have to do that research outside of school because most times they're very unrelated to what we learn in class. I would say they're more advanced, more like grad level stuff. So we need to be reading a lot of like textbooks, research papers, any current developments on any models we have.
The accumulator basically just builds the battery pack of our electric vehicle. We're the ones responsible of both designing and manufacturing the whole battery pack. And it just consists of like just taking a lot of batteries, putting them together, and just making sure that it's able to power the electric motor of the car, and then it's just able to power it for long enough for the car to be able to get through endurance.
So what we do, we design, size, and manufacture our battery pack, and it's kind of dangerous because we are using high voltage. We have to custom make our battery pack modules, which we call sub-packs, and our car is fully electric, so we use all lithium-ion batteries. Designing the circuit, putting it together in a safe, mechanically safe structure, and then being able to provide that power to the motor so the car can actually run. So it's basically the engine, but since it's an EV car, it's the battery.
Bringing the weight down does bring the performance of the overall vehicle up, since it's less weight. So if your car is lighter, you accelerate faster. In general, the accumulator itself is smaller, so it brings your CG down. So in general, it will increase the whole vehicle performance. Basically, the main thing that kind of improves on the car as a whole.
Drivetrain is the part of the team that handles the motor and the differential. So we basically make sure that all the power from our battery pack is going to the wheels, and we can output most amount of performance out of the motor and motor controller. We basically package the motor controller, and differential in the car. So we basically make sure that we output the maximum amount of power from the battery to the wheels. And we control most of the power, acceleration, and speed values of the car.
For cooling, we designed the cooling subsystem for both the drivetrain and the accumulator, so we work closely with both drivetrain and accumulator. Within that sub-team for drivetrain, we developed a liquid cooling system, so we essentially pump water through the motor and the motor controller and dissipate all the heat that generates, because during a race you're generating a lot of heat just by pumping. To drive the car, you're going to need to create power, and as a byproduct of that power, you're going to create heat in your components. We blow air through the cells because, again, as we're drawing power from the cells, we're creating a lot of heat, and we're just getting that heat out by just blowing air and then putting it out into the environment.
The electrical sub-team designs the electronic system for the car. So we have the battery management system, we have the telemetry system, and the dashboard control unit. We design the hardware, so we're the ones who design the boards, we manufacture them. So we order them from a company that will make the PCBs. They give us the boards, and then we manufacture them by taking solder paste and placing each piece individually on each board. And then we also test the hardware, making sure that there's no shorts, that everything is connected as intended, and that we get like proper voltage readings everywhere on the board.
So we have some boards in the front so that the driver can see important things about the car. We also have boards in the back. We have some boards that collect sensor data and send it over to our telemetry system. And we also have boards in the battery pack, our battery management system. When we're in the design phase, we try to ask firmware and other sub-teams as well, like what kind of features we need to accommodate for on the boards. Like for the other sub-teams, it's usually sensors.
As I like to call it, we are the nervous system of any component that we're in. We connect all of these sensors, motors, and everything that needs to talk to each other together. And we also make those things that talk and listen. There's several dozen sensors on the car. There's a whole wiring harness that needs to go in, because in any car there's a multitude of sensors. Part of what we do in Formula is data-driven design, right? Collecting data, using that data to inform for future design decisions. That was one of the huge design goals of FE12, was leveraging that sheer amount of data that we have.
Because it's an electric vehicle, our car is powered by a high voltage, about 504 volt battery. So we need to design a custom system to record the cell temperatures and voltages, as well as balance out those cells. And based off of firmware from interfacing with another board on the car, it can tell if the cell voltages are too high in one of the cells, and it will send out a discharge current to keep the voltages pretty equal. What firmware does is they actually program the boards to display the information that they need. We'll give them the design, and then they will interface with integrated circuit chips on our boards and write the firmware for them.
The firmware sub-team basically programs all of the boards that have microcontrollers on the car. So whatever board that electrical team develops, we program them, and we implement the data transmission, the safety system, the software control system. Most of our work is on testing, as well as data analysis and data visualization and collection, because all the firmware from previous years have already been working on the car. And with similar hardware, we're focused on getting data for other sub-teams to validate the designs and guide their design choices. As firmware sub-team, we don't manufacture anything, but we do have to wait for the electrical team to finish manufacturing the boards in order to test our code. And so that's the most major hold up in their timeline.
Electrical, if anything, is just like one giant setback. It's the simple mistakes that will always catch you up. Whenever you're manufacturing something, everything that can go wrong will go wrong at some point, and your main goal is to figure out how to alleviate that or work around it.
On the car itself, operations' main role is making sure that delivery adheres to all of the rule books on the competition, as well as a design that's exciting to look at. So the livery is just the aesthetic design of the car. So that's just including the different colors, the different stripes or design elements on the car. And the overall goal for our livery is to make sure that the car looks fast, it looks clean, and it looks presentable to everyone who's looking at it. One thing that we always make sure to have in a livery is to show some school spirit. So we do planning on having a cow print accumulator and a cow print headrest, which has been a tradition for the team for many years. This is the first year that we have a Aerodynamics package. So that gives us a lot more surface area to actually design something and put more creativity into it. As a mechanical engineer, I've always looked up to the creatives and seeing what they can come up with. So being able to collaborate with this new operations team this year, seeing what they can come up with, listening to different opinions, I really enjoyed that process so far.
We also have to find sponsors for the team, which is really important. We need to find companies that's willing to sponsor for Formula. Materials for the car are actually really expensive. They range pretty high, from like $100 to thousands of dollars. So finance is really important for the club.
As a finance lead, I mainly buy everything that everyone needs, but the main issue that we need a lead for is that there's a lot of budget issues, especially this year, since we wanted to keep FE11 and build FE12 at the same time. So there's a lot of increases that we weren't expecting, and we don't have much funds from the university itself, so we have to get a lot of donations and sponsorships that we weren't really ready for. It's really important because operations helps us gain some money at least. Even if it's small, any money is enough for us. We need as much money as we can, so I feel like working with ops is very helpful and helping us fund our car. And yeah, I'm really thankful for the fundraising that ops does, because without it, we'd be kind of lost right now.
And so operations, our main goal every single year is to raise as much money as possible. And to do that, we've set up like numerous different methods to do that, including fundraising events, talking to sponsors, career nights, things like that.
And then from there, we get our social media more out and have more companies see that we're putting in the work and putting in time and effort into it.
I can't feel my fingers. It's so cold. Oh, I drove. I'm in the view.
I'm excited though. I think today's gonna be a fun day. It's so awkward with the camera right there. I'm like avoiding eye contact.
Picnic Day is an annual celebration run by UC Davis, and it's a big traditional celebration for the Davis community as a whole. But for Formula Racing, it's also a tradition for us to participate in the Picnic Day parade. We use Picnic Day as a timeline milestone for getting our car running, so that we can run it in the parade, show it off to our local community, and also so that we know that we have the car running a significant amount of time before the competition. We didn't meet our Picnic Day deadline, but that doesn't mean we can't meet our competition deadline. I do think this is a failure on our team's part. I'd consider this a pretty big red flag in terms of our progress this year.
We missed our deadline, which I think really sucks to have a running car not by Picnic Day, which we had last year. We are overdue on how much time we get to test the car and figure out issues, so now everything is a race for the clock.
We're kind of playing a bit of a catch-up game now, but I think knowing that we've failed Picnic Day gives us an extra boost of motivation to make sure that we can get everything we need done as quickly as possible for competition.
This is how I control the car, WASD.
I'm looking forward to seeing the crowd, seeing how excited everybody is, and getting to talk to people who are, prospective students and other students here and talk about our car and all the work we've done.
Picnic Day is always one of the good days for, exposure to the general public and all that. So I'm excited to have everybody see what we've been working on all year.
So instead of actually running the car, with the gas and everything, we decided to actually tow it using a tricycle. So I feel like that was very Davis core.
Let's go, Eddie. Round 2.
Representing the College of Engineering, Formula Racing at UC Davis proudly presents their latest student-built electric race car. Designed and fabricated by over 100 undergraduate Aggies, this vehicle will compete against 100 other universities this coming June.
the huge crowd at the parade, the whole team being able to come together outside of the shop, seeing the whole car together. Overall, I think it was just a really great team bonding experience and a lot of fun.
So picnic day was going great until something happened.
We were making a right-hand turn on the parade, and we saw a little bit of a dip, but we thought we could make it. But the moment that we turned and actually went over the dip, the whole front wing scratched the entire bottom side of it.
I didn't realize there was a dip until everyone started going like stop, 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 and then the car was kind of just like kept going, and then I was like, oh no, and you hear it happen. I think we did a walkthrough. I had told the team to do a walkthrough. I'm not sure if we actually did it.
We were told multiple times to scout ahead, make sure that like the path was actually drivable, or plan ahead if we did need to pick up the car. But yeah, we ended up scraping pretty bad, backed up, and then tried a different spot on the divot, and we just scraped again, and ended up we just picked up the car, and you know, that was it. The main element was scratched up pretty bad, but it's nothing we can't fix for sure.
So picnic day has been something that's been a part of my life since I was a child. Since I was little, I was always on the sidelines watching the parade, and this is my first time actually being in it. So I remember as a child seeing all these engineering clubs going by. It was super exciting for me and inspirational, and I am super excited to be on the other side of that now and to hopefully inspire some people to build their own race cars and to get into engineering as well.
Yeah, I'm pretty excited to see it, you know, rolling in the parade. I think it's going to be great to get everybody to look at it and show off the work that we've been putting in this year.
Then I think while we're making a turn, we just got too hyped. We just lacked the communication, and we just.
Yeah, the second one too, I didn't really see how it happened at the moment, but looking back at the videos, that was also something that should have been prevented. I think we got a little bit too excited and pushed the car a little bit faster than we thought. And I think it ran into the back of the tricycle.
I was heated. In retrospect, we definitely should have just debriefed everybody about the state of the car and how we don't have brakes. And I ended up hopping out the car, inspecting the damage, and just covered it with some vinyl. It made me feel better, for sure. We ended up cracking a good portion of our front wing, but most of it is repairable. We can bounce back for sure.
It could have been worse, yeah. I think it definitely could have been worse, and this was a good warning for us to make sure that we're handling the car with care moving forward. Hopefully from now on we won't have any more casualties like that moving forward.
Perfect, thank you so much. Keep an eye out.
If you run fast enough, you'll take off.
It was a great time. Loved hanging out with all my friends and getting to showcase our car.
Yeah, pretty fun, you know, chilling out. Basically a long Formula meeting, as always, you know. Yeah, got to talk to a lot of good people. Yeah, it was pretty good.
It was good. It was fun, like seeing everyone cheer us on. That was very encouraging.
Yeah, I agree. I'm ready for a nap.
I'm also ready for a nap.
Yeah, I'm ready to just go home and chill for a little bit.
I danced for too long.
Good day. Have a good
Wait,
day.
you danced, Melody?
Yeah, during the parade.
I didn't see.
I'm gonna do some work on this one right now. Okay. So I'm gonna put this back.
Do you want one of these guys?
I will need those. So, well, these we weren't able to find. Okay.
Picnic day went great. Obviously the car wasn't running, but I think that was better for safety and just like overall running. I thought it was amazing. It was really funny seeing Victor go around with the speaker. These boards right here, some of them, we weren't able to talk with them both ways. We were only able to talk with it one way. And ideally, if we can talk with it both ways, then we can chain them together within the accumulator. We need each of these boards for each sub-pack, so we can manage cell balancing and also cell charging. But because we didn't have all of them functional, we can't safely drive on picnic day. And we weren't able to fix them in time. We tried to with a pretty jank fix by routing wires around the board like this, but unfortunately that didn't work and made the problem worse. So either we would only have 2 function sub-packs on picnic day and risk burning out everything, or just running with no accumulator and pushing the car through with rolling chassis. So we chose rolling chassis instead. I enjoyed it a lot, and I think it was, I mean, picnic day is going to be picnic day, right? It's always a little bit chaotic, but it's very fun to be with the friends that I have.
All right, so let's give ourselves a round of applause for finishing picnic day. I'm just super proud of the team for getting this far. We got the car to get rolling chassis for picnic day, and we had a front and rear wing on the car. This is the first time our team has done this ever. So a huge milestone for the team in the long run. The biggest thing is we didn't make our milestone for having the car running. If you guys were at the parade, you saw we had to tow it with a tricycle. We also pushed it in some parts. So reflecting back on this, I think we have to think about how we can get back on track for competition. And this is picnic day is just a great reminder of like where we should be at and if we're behind, things like that. So our next basically priority is getting the car running as soon as we can. Although we didn't meet some of our goals for picnic day, it was still a very successful day, and we have the rest of spring quarter until competition to work really hard on the car.
This is axial cyclic movement, right? This has nothing to do with your movement up and down.
No, but like
the whole car is vibrating as well.
Next time we record, do like a visual cue for when you start. So this right here is your low voltage switch. When you say LV on, this is what I'm turning on. This doesn't access the accumulator or high voltage at all. This is your shutdown close switch. Functionally, as far as we are concerned, this is gonna be your HV on. This thing right here is an E-stop. This will open the shutdown circuit. If you're near it, any problems, if someone tells you to slam it, just push it. Same one on the other side. And for drivers, there's one on the dash. For drivers, these two things up here, your blue switch is HV on. This will get you into HV request. And then when you're ready to go, this red one right here is your drive request. So in the case that you need to turn it off, in an emergency, hit the E-stop first. When you need to get out of HV, close these two together.
And then open the shutdown as soon as you can. Actually, this also.
Yeah.
On in 3, 2, 1.
That was 100 miles an hour. That was 100 miles an hour.
You like the line?
Overspeed? I don't know.
We're cooking.
Oh my god. Is that 3, 2, 1.
I think FP11 went that fast. No, definitely not. This thing is fast.
Even on like flying laps, that was like,
oh my god. Imagine sitting on the ground.
I'm actually so happy, dude. I genuinely didn't think we would like get it running, but we pulled through. We got it. I'm kind of worried about brakes, but like that's fine. We don't need to worry about that. But yeah, I'm honestly like, if we can get like a good shakedown or like a good like full throttle like everything on there before comp, I'm kind of confident. I think we can pull some ranks. So yeah, we'll see how it goes.
Alright, we are going to attempt to run the car for the very first time on the ground. 12:44 a.m.
No, we're lucky.
Night has only just begun.
Yeah. But it looks like we have a good feeling though.
We're gonna get 100 miles per hour top speed right now.
Right now.
Putting it down.
Victor is the spring race pack.
It was the morning. 65 kilograms.
What's that in American?
I have no idea. Like maybe like 150.
You know, no brake at the same time as gas. Just it's really
It's
last year
overridden
was really
right now.
sensitive, so it should be okay.
competition, there are a couple different stages. So there's a technical inspection and an electrical safety inspection. We only get 3 days to pass competition or pass inspection, and if we don't pass inspection, that's it. Our power competition's over. The rest of that is static and dynamic events. So static events are mainly more focused on the engineering design as well as the business management side of your team. And that's where we have industry leaders in the automotive field talk directly to the teams and pick their brains on how well they understand the design that they made and how well they understand overall the vehicle works. At competition, there's 4 dynamic events. This consists of an acceleration event, a skid pat event, autocross event, and then the most important one is endurance. The car has to run for the entire 22 kilometers to get any points for that competition of endurance. The teams that do finish kind of gives you a guaranteed spot in top 10.
Alright, y'all turn.
One down.
Alright.
One down. One down, 5 to go.
Down, baby.
Woo!
Next up, back tech.
Yeah, Heather, like we could take off, we can dismantle one of the
No, you-
walkie-talkies.
You want to spread it out here?
That's okay.
So all of those people I just said, remember we're gonna wake up at 6 a.m. We're leaving at 7 sharp. Earlier if possible. We're gonna try to get to comp at 7:30.
If you're not doing anything, try to go around and look at other teams, get ideas from their designs, or there's also career booths. So if you're looking for jobs or internships, go talk to them. Just try not to like be not doing anything. Be active. It's comp. Like there's a lot of opportunities. So.
And then 7 p.m. we're turning in our AC.
Okay.
Okay, that's it.
So one more thing with like going straight into EV tech, the one thing I want to make sure that is accounted for is that we can go into HV safely. Head's gonna start with that first thing in the morning. Ideally, that gets figured out. But
you're not gonna have the car in the morning. It's gonna be a mech.
Yeah, I know. But we can test on the bench because the issue right now is a discharge resistor. We can simulate its behavior with a power bank.
Okay.
But we need to be prepared. That might take a bit longer if we're like.
Okay.
That
That's
needs
fine.
to be done.
Yeah, that's fine. Yeah, that's fine.
That means the rest of you guys at the paddock need to leave him alone. Okay?
Yeah.
We need people around. Stay out of his hair and let him work.
And if he starts to yap with you, please tell him to
Do
walk
not
in.
talk to him. Do not talk to him. Just
Okay.
let him. Just let him work.
So people in the paddock, just a reminder, we don't want you just sitting there all day. You guys should be up, talking to other teams, talking to sponsors, doing your networking. Just don't sit at the paddock all day. You should be busy. Okay. Get to work / go to sleep.
I'm going to take a shower, bro.
Take a shower.
No. I don't know. Get rid of it.
So this is day 2 of competition. We're really focusing on passing our mechanical tech inspection today, because that means we're going to have to go through SES tech. After mechanical tech inspection, we want to get through just the basic stuff that we need to get done, so vehicle scales, and then hopefully start on EV active tech inspection if we're able to finish mechanical tech inspection. So it's going to be a really busy day, trying to get through as much tech as possible. We don't think we'll pass EV tech today, but we still have all of tomorrow to finish it up. So right now the team is working on just getting those last minute changes in. We're going to immediately go to SES tech, get the process started. I'm pretty hyped. I think everyone's super locked in right now. Yeah. So we'll see how the day goes.
So SES Tech is when they go through all of our vehicle parameters and make sure that we are in compliance with that, and also in regards to all the rules related to the chassis, aero, and all the bodywork. So yeah, we'll see if we pass SES and if our car is in compliance with rules.
They're gonna use trig to measure the heights. So they have the hypotenuse and then the angle, and they measure like
Please stop your sheltering now. Lightning is now within 4 miles of the track. This is not a drill. This is what you must do. Shelter in tanks, in buildings, in the suites, not vehicles.
Hi. What's going on? We parked the car. Dude, I think all of us need to pass rain tech because of this. It just started pouring, dude, in the middle of preparing for mech tech. We were all in line. We were carrying the tarp out, or the I realize I'm looking at the car and I realize like, oh no, one of our cables does not have the waterproofing on it. So I sprint back to the paddock, get the stuff, and by the time I'm here, it's like I already feel the rain like clinking down. So I'm panicking, trying to change this connector. They end up just wrapping it in a plastic bag. So yeah, we're just getting a DIY rain test right now, and I don't know if we're prepared for it.
If you go outside right now, you will get disqualified as an individual, so don't go outside.
As an individual? Yeah.
The actual call-up is just goes into this. But there's no total score.
You'd be on radio.
Okay, I got you. We're in station 1, which is mostly bodywork checks. Fortunately, our nose cone doesn't pass the minimum radius check, so it's a little bit sharp on a few edges. So we're just gonna figure out a quick way to round out the edges a little bit with some cardboard and duct tape.
These are brand. We have a brand new set anyway.
And you can get banjo bolts that are like 90-degree banjo bolts. I highly suggest getting those. Yeah.
One of our brake lines were rubbing, and like Chris warned us a couple times, but it's okay. We have an idea for our solution, and we have a bunch of checklists of stuff to do anyways. So hopefully we can get it all figured out and then come back.
I think that's all the team.
Do you have any?
It's not. I don't have electrical tape on. Can I check all?
I think Edwin has one. Oh, hold on. Yeah.
I think we got called out on sharp edges. We're basically just covering in duct tape, so it quantifies as the removal of sharp edges. But obviously it's not going to look great, but it's okay. I'm more worried about us being out of the bounding box for the rear wing, because the guys seem to like have to stick up, and he seemed to be pointing and Elijah was taking photos, so that's not great. So we're either really close or we're off by a bit.
Are we gonna go to scales after this, or are we gonna?
No. Yeah, we have to go fix.
We can't enter scales till we fix.
I don't know, actually. So what we can do is just trim this if we have to. The thing, I think the bigger thing that he pointed out is the reason that only this side was too far back is the wing isn't straight. Yeah. So if we fix the wing straightness, that might just fix the trailing edge issue, and then we either lower it or we chop it.
Who's garage when we did registration?
I went
right next to the paddock entrance. I know where it is. I'll take the guys. Are you gonna remove the tape off of this?
That's fine.
We have everything else here.
Because he's for sure gonna comment where this model.
We need to double check the front wing like minimum radius rules requirement, and so we're gonna 3D print a jig to double check that for tomorrow.
8 a.m. is when design scales open. We're gonna try to be there as soon as they open. Design scales hopefully only takes us like 20 minutes. So that gives us about 8:30 to 9:30 a.m. to work on the car. We're gonna allocate that for Aero package to fix their bounding box issues. During cost event, Manny, you're gonna work on firewall. Prepping firewall, and then as soon as we're done with cost event, we're bringing the car back to the paddocks. And that gives us until 1:30 to fix everything we need for mech tech. So you have all that time. You gotta get it done.
Okay. For the brakes, I want to appoint some people right now. Audrey, you can help. And then I need one more set of hands. Maybe Dino or David want a wheel package. Bryce, you want to do it? Yeah. Okay, I'll get Bryce. Yeah. That's good.
We have between after cost event and between design event is all we get to fix everything we need for mech tech. So here's all the things we need to fix for mech. First we're going to take off wheels so Sahil can work on brakes. He's going to flush out brake fluid for the front and rears.
Just fronts.
Oh, just the fronts. So Dino and Bryce are helping you out with that. Hopefully by 11 a.m.-ish, Manny, you can get all your firewall fixes done for chassis and also finish grinding out your tabs. Then we're going to take out all the brake lines. Nose cone needs to be taped up, and then jet nuts need to be installed. So that's David and Dino. Okay, so that needs to be done before 1:30 p.m. 1:30 is our design event. Everyone should be there. So.
No exceptions.
Yeah.
Design is the most important event. You should be there.
That will be the end of our day. So we'll be out at 7:30. Also, this is for design event. I'm gonna post real quick. Basically, our team-wide goals, the splurge that I'm gonna do for the whole team. Just make sure you read through that and practice your own splurge for your own individual sub-teams. The idea is we wanna. Splur, what is it?
Wrong word, bro. It's a blur.
Splurge. Pull up to the judge. Splurge.
It's not an expensive process.
Wait, I want to join group practice.
Give us points, here's a 20.
With enough money.
I'm sorry, bro. I just can't.
Manny started it.
It's not even a newsletter.
Put
that in the newsletter.
This is my public speaking. Okay, you guys know what I meant, okay?
Oh, we know.
Your own
We know what you mean.
Okay, that wraps up today. So we have an early morning tomorrow, everyone. I will post everything I just said in a bit.
Did they kill it with like that?
It's so chill. Sideways PM. We have to be awake in 3 hours. The last all-nighter of the season. That's probably not even true.
It's not an all-nighter. It's not an all-nighter.
Not yet.
Transient system level problems. Okay, I guess
I think I see the
okay,
vision.
that makes sense.
How's it going?
I'm tired.
I'm also very tired. Well, I took a shower. Wait, after you met, you probably have time to take a shower.
Maybe.
No?
I think I'm a mesh and then take a shower.
Yeah, okay, I think that's fine. I think that's fine. Night.
Okay, everyone else, if you're in the. We are Formula Racing at UC Davis, and this will be our cost scenario presentation. So a lot of our parts on the car are machined, especially the ones with more complex geometries.
And then pulling all these changes, we decided to change our cost report. And with all the reductions, we actually found that our reductions lead to 20% rather than our goal.
It gave us a preliminary number, but it changed it. We need to mount less than a brake cap onto your system. Stuff really high. So that's what we have to sensor.
And then if you're trying to get the car ready to run events, we
within reason, we can come to you. So we'll see where you are. Okay.
My schedule for tomorrow? I have my schedule for today!
What the? But like all in all, I think it went really well. Like first year Aero team, like we learned a lot. I think he's gonna give us some really good feedback.
That is true. And he was like, so have you like for tomorrow for the dynamic events, have you considered like how much time you need to charge up the accumulator and like how much time you need to charge the accumulator, how much time it takes to take the accumulator out, put the accumulator in.
What the? He wants every second.
He wants everything. He was like, do you know when to like when you're gonna go pick up the accumulator, put the accumulator in the car, go to the quick circuit? I was like,
Even in the braking stuff, it's like, oh good, how's your braking performance? We don't know. Theoretically, it's good.
The guy asked us how much drivetrain do we have.
Yeah, and I said like
they asked us the same question too.
The judge, he wanted to see like a detailed schedule of our entire competition. Did you have it?
People have it.
Huh? Well, I mean, I do have one,
It's
but
supposed to be like, if we don't pass mech, then we do this. If we do pass mech, then we do this. If we then pass electrical, we do this.
I saw.
wait, I do have a schedule. You made in Discord. I did make one. Oh my god, I could have showed him that.
0 people in line. Let's get our shit together and go. Alright, great. So let's get the cardboard out.
Can you add so that we're like back here?
Look how much cardboard we got.
Yeah, wait.
I didn't care about that.
Let me check the rules.
Like even though the ambient air temperature is
5.
just the sun.
Let's go. Come on.
Passed the firewall check.
Nice.
Passed the left.
We're going good.
Yeah. We've passed every section retest so far.
Good. Congrats. We're getting there. We're coming along.
next is aero stuff and brake stuff.
I think aero's a flat one.
Brake stuff is the hardest one.
I got you. Crazy, yeah, but I don't know.
Jane, we're bounding box? We're bounding box? Bounding box. No more fumes, no more fumes, no more fumes.
We passed, baby!
Stay in school. School is cool. Engineering is bad.
Hell yeah.
All right. We got mech tech.
You know, it was really exciting. I'm tired as hell. I think I have like 4 days of sleep that I like don't even remember falling asleep. But yeah, low-key in the driver meeting I was falling asleep a little bit too. Yeah, but we made a lot of progress. Work is not done though.
So, today was going great. We passed mech tech, and then I'm like, oh shoot, it's our turn. So I run back, and I'm kind of frazzled because things are not going as we expect them to. We realize that we're probably going to have to do some really janky stuff in order to get through EV tech tomorrow. So my mind's all over the place. I'm really frazzled, right? I see one of my friends from another school come by, and I'm like, wait a minute, other teams have parts. So I ask him, go over. We find out that they might have the part that we need. I don't know the part off the top of my head, so I'm like, I need to go find head. So then I start booking it because I don't know. I don't know. I start booking it, and then my foot gets caught in a groove like this, but it's perfectly foot-sized, and I'm going at full speed. I'm a bit of a heavy gal, so that's a lot of weight, just like. But I keep running through it because I'm like, oh yeah, like I'm almost there. And I find head. I tell him to go to the pit, and then I realize that it hurts, and then now I'm in pain. But not emotional pain anymore.
I'm gonna be planning out a best and worst case scenario, and so we can play it by ear tomorrow. Pretty much. Yeah, it's gonna be pretty uncertain what happens tomorrow because it all really depends on whether or not we pass EV tech.
I hope.
Are we allowed to tell the judges ahead of time that we are not able to see?
I don't think so.
They're not even close.
They're not gonna accept it. No, it's high voltage.
And I'm not saying that they'll let us enter high voltage. I'm saying that like, can we do the active steps leading up to the high voltage entering, but then stop there?
There's nothing else.
Is there nothing else before?
No, because all your safety checks are for once you're
tech and tech.
Well, it doesn't matter unless you're.
They check your GLB and your high voltage slug in mech tech.
Yeah.
It doesn't matter. Yeah.
Okay.
Like,
Relying on the fact that someone.
we did what we could internally as a team. If we had gone in as we had 2 weeks ago with our status light, we wouldn't have red card, but we would have failed EV tech thanks to the fact that the status light would have turned on at way lower than 60 volts.
Is there anything else that we need to figure out right now? Okay. Alright, thanks for your time.
I think, I mean, EV is like a big one, and I feel like, I don't know, it's gonna be hard to get EV because even with our timeline tomorrow, it's cutting it close even if we get EV to pass. Because after EV we still need to do tilt, brake, and rain test with driver egress. and we want to get some practice runs in before an actual like dynamic event. And we want to do acceleration. So even if we get EV past, like a miracle happens, we still need to hope that every other test is good, like tilt, brake, and rain. I'm low-key a little worried about brake, because I literally just like re-bled the front brakes with new fluid, with like a completely new like line and fitting and everything like that. And I was kind of rushed, but pedal feel seems fine. And I probably just need to tune it, but I think brake test is one of the ones that I'm kind of worried about. But yeah, I mean, all this is like this is said with us passing EV, and I'm not that confident, especially with just the mess ups that we've had recently. I don't know. We'll see. I'm kind of being pessimistic, but I don't know. I mean, I feel like it's the only thing we can focus on right now, so might as well just stick with it and not give up. Yeah.
The situation we're in, it's going to be pretty difficult to make a full comeback to get all the dynamic events. Considering that this is the last day, we have to pass the rest of all the tests and also complete all of the dynamic events. So I think the main goal is just to see how far we can get. If we can complete EV Tech today, I think that's going to be a really good milestone for the team. And honestly, I will be really proud of the progress we've done this year. So I think I haven't completely given up yet. It kind of sucks that there's not much I personally can do to help out, given that it's mostly like an electrical problem, but I see how hard they've been working, and yeah, I haven't completely given up on them yet.
Most of us don't know what's going on, but we see the effort, like it's not going to waste.
Honestly, what they've gotten so far, like they've gotten a running car before already. That's already pretty impressive.
To give you a copy of the rubric, which you can of course read online. And also, if you take the scores that we gave you on each sheet, and if you add them up, that's not going to be your score. They're going to normalize it. Were we too harsh? Were we too nice? What is the range that is being assigned to finals? They don't know yet, so they're going to even all that out. These scores are not like school. So at school, 50% you failed. Here, 50% is average. 50% is you kind of did half the stuff that we're looking for, and they want us to use the entire range of scores when we are when we are assigning scores to the teams that we have. And we do, you know, we did see in our queue, you know, range from like, okay, you know, really good team, all the way down to, you know, really beginner team and everything in between. So we definitely use that as judges.
If you were to ask the people at the very top what this competition really is, it's a program management competition.
You are the products of this competition, not that. Everything that you have learned and all of your skills and all of your real-world experience on this car. All right. Well, let's pick up where we left off.
I think we want to move a little more that way.
Sure. So we stay out of the way of the car.
Yeah.
We want a car that has a decent overall grip, right? But importantly, you want it to go where you point it, right? So if it's going a different direction than where you're pointing the steering wheel, right? That's not balanced, right? So I'm just asking, how do you get it balanced, right?
The numbers can be equally as accurate, right? There's obviously some processing, so the accuracy, the estimation between the points, or maybe if you oversample in the background and then only record, right? You sample every 5 milliseconds and you record every 20 milliseconds. That would give you 4 points to average or do some kind of low-pass filter on or something, right? So that you didn't have to worry about Nyquist frequencies and stuff like that. So increasing sample rates can lead to more accuracy or help you see the real signal through the noise, but it is not in and of itself inherently more accurate.
Right. When you're designing like cell interfaces, it's kind of like we're going to be asking you questions in like design finals about like how did you engineer that specifically, and so some questions that might come up might be things like can you show me how you designed this fuse, and obviously fuse is going to take a lot of empirical testing to get right, but also you should be able to tell me from the first principles basis like the fuse is a wire of approximately this length, it's going to radiate most of its heat away, it's going to conduct some of its heat away to the neighbors. What do we think the optimal fuse length should be? The motor size that you choose is going to be based on like, can we get a better performance? Is it significant if we make the motor 50 kilowatts and like extra torque?
Well, it's super unique. Like, you know, in a company, you could be there for like 10 years, 20 or whatever. Formula, it's like 4 years. People cycle through, and then it's always like brand new people that like don't know anything, freshmen, and then they make their way through. So Formula is very unique in that way, and that makes it difficult. So you have to like put extra effort into like knowledge sharing.
The whole chassis is a spring. Yes. It's a series of springs. You have obviously the suspension that's doing its thing. You're trying to transfer weight fore and aft, left and right, laterally across the car. I always like to ask the question of what is too stiff, or like what's the downside of being too stiff. Do you guys know what that is? It's just mass. Like, too stiff means you're too heavy. There's a limit at which you are not getting value back out of that mass, right? And it's good that you know that.
I've really come to be strongly of the opinion that like a tablet or a laptop where you have all of your stuff ready to go, organized at your fingertips. So I'm asking you some weird question and you go, boop, 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 boop,
Yeah,
you know, here it is. I think we've got a graph about that. Scroll, 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 here it is. You're allowing yourself to turn all of your management decisions into a cost-benefit analysis. And the cost is what it takes you as a team to do it, and the benefit is the competition points. Maybe you will sit down after you've gotten some sleep, and you will go through and just everything that went wrong for the year, and say what went wrong. And then team, we're all smart people, how are we going to avoid this in the future? And a lot of good ideas are going to come out of that. What did we learn? And everything's experience. You have learned from experience, so like it's just going to be better because you are more experienced.
Let me go answer this question that Michael had.
Of course, yeah, please go ahead.
It's really the
First project management design unit.
Wow. Crazy. How does it feel? How are you feeling?
I feel really good.
Yeah?
I'm so excited. I think I've just learned so much this past few days.
Yeah.
I'm like, I have so many ideas. I'm so excited.
Are you excited for next year?
I am.
Yeah.
I'm like, wow, I now like know what we're missing. Or at least it kind of feels like I know what we're missing now.
I heard you were the lady in charge.
I am. That is me.
My only singular advice would be, I think you guys, especially these guys have tons of talent. I would, at the beginning of the fall, I told them like you will finish how you start. So start with the end in mind. And what I mean by that is, figure out what, and maybe this is what Skid already said, but figure out exactly what your goals are going to be for the end, and say, okay, and it might only be like 3 things, this many points, or we're going to pass this tech, or we're going to do this, we're going to complete these events, or whatever it is. Here's our goals, and then say, if it does not help us meet those goals, we are not doing it. So you're going to be Mrs. No, okay? You're going to be no to everything, okay? That would be my advice, and they're going to hate you for it. They're going to be like, oh, but this would be cool. So he's like, look, I got this cool design for the brakes. Yeah, you already know what they are. Yeah, exactly. I told her. Exactly. Yeah. So it's like none of those things, if they're not taking us to that goal, And there's two reasons for that. One, it's going to make the car better. It's going to laser focus the team. It's going to help the culture of the team because it's like we're all on the same page and we're all like helping each other meet these specific goals. We're not like a separate team. We're all doing separate things. And like I hope it works out at the end. It's like, okay, this is what we're laser focused on. And then the second thing it's going to do is going to help you in design specifically because every question is going to naturally be answered with as it relates to those goals. So when I say, hey, how come this is the same rotor as last year? They don't have to be like, oh, I don't know, it's what we had laying around. They can be like, well, because we chose only to do these things, and the rotor was not necessary for those things. Now, they'll have to have, you want to have, like, and I've talked with them at Lynx, so they already know this, but they'll have, like, very specific, like, we analyze it to make sure it's still good enough for the mass of the car and good enough for all these other things, but here's why it wasn't worth, sure, we could make it better, but here's why we didn't make it better. That is, to me, that's a 15 out of 15 for my category and for the other categories as well. That's a top design score. Is I didn't do it, but here's why. As long as you have a good why. It's like you have to build slow and build up. You try to go from here to here, like you trip and fall, and then it's demoralizing, and then people quit, and they're like, oh, it sucks. You want to be like define your victory so that you win every year. You know, I'm excited to see you guys come back next year. That's the fun part. Is to like see next year. Very good. Very good.
We're done. 12 out of 15.
Yes.
Let's go.
Let's go. Apparently in the top like handful of teams that had Aero this year. So
Yeah.
I'm very proud of that.
We didn't make any big mistakes, just things that we didn't do. Next year we can bounce back even better. Like we say in our sub team, there's nothing more permanent than a temporary solution. Right?
Oh my God.
If it worked, it survived picnic day.
And the design judge loved it.
Yeah.
So
Actually, I think we won, but
that's sticking.
Yeah.
Printing foils is sticking on next year.
Yeah, and not like fully printed foils, but being able to like optimize with 3D printing is something that not a lot of teams do, and that really set us apart.
I have to attribute it to Chris, because he told us like we're done with everything. We finished manufacturing. We damn near had all of our aero maps done, and he brought up a point that we might be really understated. So he said, why not just like build something, chuck it on, and then test it throughout the rest of the time, and cut it close, but we still made it.
And then just assume you have like 10% of the work that you think you have.
Thank you, Chris. Thank you, Chris. It changed up a lot of the concept of how we approach it. And like our goals kind of shifted as we kind of decided not to make an under trade.
Yeah.
Right?
So should we celebrate 412?
Yeah.
412. Oh wait,
now it can be a celebration.
Yeah. Now it's a
412 is picnic day.
Yeah. Arrow's come back. Arrow's come back.
Yeah, but look at the front wing like change really showcased like our design skills. Like we literally went back to the basics of 2D sims, moved to 3D sims, validated it all, figured out how to manufacture and mount it on the car, like, and then created documentation.
It's been like 3 weeks, right?
Yeah, in a really tight design.
Yeah.
She went through it this year?
That's true. So who'll be
Not
winning
gonna
next year?
happen.
Yeah. No, I lock in now. I actually know what I'm doing now. Yeah. Like, I've had this mentality the entire year that I'm like, oh my god, like I don't know what's going on. I have no idea what's. But like I sat down yesterday, I thought about. I'm like, I know what's going on.
That's good.
It's just hard.
It's just it takes a year of suffering and struggling and like breaking everything.
I think I asked you about this earlier in the year. Validate suspension pulleys post build. So I measured it by hand, which he was like okay with, but I think I asked you about 3D scanning the chassis. I think that'd be really useful.
We could do that next year.
Yeah, I think that would be also useful for you guys because if the chassis is slightly warped or bent, which it always is, your wing is slightly bent or warped. If I had time and if I had known earlier, I could have fixed this because I've done this before. I thought about staying, and my first thought was like, is it really worth it for you guys if I stay? I don't think it's worth that much. Because I think, it adds that much if I stay. Like, the only thing I do is organization.
See how many points we can gain if Chris stays.
Yeah.
So right now it's just
Final call? We make the final call.
I think it
we
was
have
already
30
made for
minutes.
us.
It
We
takes
made the
15
call.
minutes.
Yeah, I think the call
Alright,
was made.
it's done then. Yeah, we're done.
Yeah, it's been. I feel like it's been a while, but like now we can finally say definitively that's not happening.
It's all
Jimmy, you guys did a great job. You need a big hug. Let's do it.
It's
You
all
guys did,
right.
I know, serious. You guys did a great job. Oh my god. That was a good one, okay?
We should still clap for our efforts. We got MedTech in. We got MedTech in.
Okay, yeah, so in other words, we weren't able to pass EV technical inspection, which means we have nothing else to do. We won't be able to participate in the dynamic events or endurance tomorrow. So, competition's pretty much over for us. But we still are going to be here for the rest of the day and all of tomorrow. So I want you guys to take use of this time and learn and debrief and talk to other teams. Rest a little bit maybe as well. I'm still really proud of the team we made this year. We honestly did so great, and like I just want to say I'm so grateful and I'm so proud to have all you guys as my teammates. Oh, I'm so about to cry. I think we're gonna do really well next year. There's so much to improve, and like I just wanted to say, like electrical, we saw you guys work your ass off. Stop! I'm gonna cry now too. I'm out of tears, girl. I'm too dehydrated for this. I know you guys probably feel like all of this was on your shoulders, and it was all your fault. Please don't think that. It is not. And like I think we all share the same sentiment that we appreciate all the work you put in, and we can't wait to see what you guys come up with next year. Yeah, for X13.
I also just want to echo what Heather said. I've been very proud of every single one of you, not only from what you do professionally, but the growth that you've had personally. I've seen every single one of you develop your skills, learn. So much knowledge has been fostered in this group. Personally, as a graduating senior, I know I'll be around for grad school, so you won't miss me too much, but I know that a lot of the other graduating seniors are heading out and going different directions and starting a new chapter. Personally, Formula has been such a rewarding experience. Very, very grateful to have joined this club. It was super rewarding, like working on such a cool project, but also seeing everybody grow. It was really great to see just everybody develop. I don't know, I'm just yapping anyway. But yeah, all of the alumni will still be here to support everybody. We want to see everybody do the best that you can. So we'll stick around to help you all. This won't be a goodbye, it's just a see you soon. And yeah.
I think it's really important that we give Heather her flowers. I think she did a really good job in orientation. I really wouldn't have been able to do a lot of this stuff without the members that I had. We wouldn't have been able to do all this stuff without the funding that you got for us. And we just want to show our appreciation for you. Round of applause.
I think this year we have some good vibes. Yeah, I think everyone was chill. Everyone kind of just agreed, and I think like having like a PM like that, just being kind of open and being like happy to talk to. It's just good. I think just us as a team is just we're good. We're a good team. Yeah.
A lot of people, you see people happy, and you see people at like the worst spots. Like whenever you encounter problems, it's like really hard, right? Everyone wants to get the car running. You encounter problems like, let's say like water broke, boards fried, no dried, like no matter what, like even at the end on finals week, get it working. We keep it was just really nice to see everyone that's still committed, still trying to like try their best, car running. We're still making progress to the last time. No one gave up. It's frustrating, like things don't work. Like we set a plan and then like everything goes different from that plan. But I'm just like really proud of everyone. Like just keep pushing to the end. Like even if it doesn't work, well, what's the next thing we can do? Like what's the next step? Maybe that's not the plan we do, but like what will make it work now? What will make it safe, right? We want to prioritize everyone's safety. When you push FE12, what changed? Like Neo came later, Aero, a whole bunch of other a lot of stuff like we went in winter quarter knowing that it's gonna be really hard, and like all the other obstacles that appeared winter quarter, like stuff with delay shifting, barrier circuits dropping out, water jet, like all that stuff. Like it's still what's happening. Like once it was up, we were ready to go, and like really proud of everyone. Just like no excuses, let's keep going, keep building. Like boards fried, reorder a new one, get back in the lab, make new ones, keep testing. So I feel like that persistence is what we need and really will help us like next year and for the future and just in general. I'm really proud of you all.
I feel like on behalf of electrical, I gotta say something. I couldn't have asked for a better group of people to work with. I think one thing that I've talked about with a handful of you guys that you guys have probably all seen is like, you know, mechanical kind of has each other in terms of how interlocked your systems are. With electrical, we're kind of on our own, right? Which means like, you know, when we come into problems, like it can be, like a lot of it kind of falls on a few people to try to figure it out. But like, everybody's patience and support and understanding, even though it's probably something that's so frustrating when it's like, it feels like the same problem is happening again and again. But like, the fact that everybody was being so supportive and just like acknowledging the efforts and continuing to like put in, you guys are amazing people to work with. I've learned so much from all of you. Like, you know, I think I'm tripping over my words a bit here, but thank you for everybody's patience, and I hope that, you know, you were able to learn something from us the same way we were able to learn something from you. You know, I think we have it down now. This has been a learning experience for everyone, but I'm confident in our ability to keep moving forward and to come back swinging next year. I love you guys.
Anyone else want to say anything?
To FE13.
To FE13!
Mess it up.
Reflecting on our accomplishments, I think just completing like the design and actually following through and manufacturing and learning a lot. I think especially my knowledge compared to like exactly a year ago, I'd say like is completely night and day. I think just having that base knowledge of like what it takes to make like an actual like full aero package is definitely something that I'm going to be fond of looking back in the future.
I'm really proud of how far the aero and composites teams have come this year in implementing our first aero package. You know, I've been involved in the aero development from not necessarily the very beginning, but certainly this whole year, this whole competition season. And so, yeah, just really proud of how much we've been able to accomplish, how much time we've put in, and you know, lots of late nights manufacturing all the components, and yeah.
FRUCD is really nice. You know, it's an opportunity for engineers to make mistakes, and I think mistakes are probably the best way I've seen anyone learn. And because we have such a fast schedule and tight pacing, 3 months design, 3 months manufacturing, 3 months testing, and off to comp, you get to see those mistakes and iterate on them much quicker than I think a lot of other teams do, or a lot of other competitions. And it's really nice because I've seen myself improve over the years. I look back on the things that I designed, like, wow, it was awful. And then I'm like, oh, I know how I can improve on that now. And so I think I'm a much better engineer than I was, a couple years ago when I was first starting out.
I wasn't sure if I was the right person to be one of the electrical leads. I felt at the beginning of the year that my skills were insufficient, that technically I didn't know everything that I needed to know. And in terms of my leadership abilities, I wasn't sure if I was good enough to help lead the sub-team. But being able to manage both the technical side, but also sort of the teaching and mentoring side with new members, I think my leadership skills have definitely improved a lot as well. And I've heard from my members that, they think that they've learned a lot this year, which that feels like a big accomplishment for me as well, because I know that something that I'm passionate about, I'm able to share that and make a college experience for these new members on the team. The FRUCD community is not something that I think I've seen anywhere else. Going back to why I wanted to join a engineering team, I wanted to sort of have this sort of this community experience, and I definitely got what I wanted and more when joining this team.
I think if you want to be a part of Formula Racing at Davis, they're definitely welcoming people. You get to know everyone. Although I'm not an engineer major, I really felt like I got to know engineering more.
I'm proud of this team. I'm really grateful for the people that I've been able to be around as a result of being in this team. And yeah, I'm just thankful, really.
The two things I like about FRUCD is I really like just interfacing with all the people. I feel like we all have a similar passion about race cars are cool, so we want to let's make one. And I just think the skills, the second part is that you just learn so much from working hands-on. Being forced to have to figure something out, like, oh, I need to learn how to design this, and you need to learn all the science behind it, or all the physics and engineering behind it, and it's just really interesting learning all that and actually being able to apply it. So just those two things, getting to work alongside people who are also doing the same thing, and also being forced to do it yourself, has been my two favorite parts of FRUCD. And in the future, I think our team has a lot of room to grow. So I'm hopefully trying to set up our team in the future to, potentially take back maybe back-to-back first place trophies in the future.
As for the future, I'm excited. There's a lot of growth in the near future that's possible for our team. And yeah, I'm excited to see where it goes.
We all give Heather a shout out. That's my PM on 3. 1, 2, 3,
That's my PM!
I think you guys are the coolest people ever. And I'm like, oh no, they're not gonna listen
Genuinely
to
so.
me.
We all listen.
I don't deserve to be your guys' boss. You guys are
No,
too
you
cool.
do. We don't deserve you. Exactly. You're so nice to us during leads.
To all of us being a pain in the ass.
Exactly.
Now we're like, oh, we gotta spend $10,000.
I would say being a project manager for this team is definitely the #1 hardest thing I've ever done in my life. Being a male-dominated field has never really bothered me in the past, until you kind of go into this team and you realize, oh my god, there's like 50 people here and I'm the only girl. And you kind of think about yourself and you sort of self-reflect on that, and question a lot of belonging, whether or not you belong somewhere. And there's also sort of that constant fight with your mind, to be like, yes, I do belong here. I can say things, I can present my own opinions. And I definitely learned a lot about what management means and what working in a team means, and the sort of nuanced stuff you have to do to make sure that a team can work together fluidly. I just really appreciate the culture that we have. I feel like eventually it came into a way where we really work so well as a team, and we're not just co-workers, we're not just people who work together. We've really become friends. And that's helped me grow a lot personally, and feel a lot more comfortable working in a group like this. And yeah, I'm really excited to continue this culture where everyone feels invited. And not only are we building a really cool thing, but we're also building lifelong relationships that we can look back to for the rest of our lives.
Yeah. Ready? Yeah?
Yeah.
All right. All right. Level John. 3, 2, 1.
Yeah, good.
All right. Shutdown close. 3, 2, 1.
Okay, VC fault.
All right, calibrate.
He was good.
LV.
All right, HP request. 3, 2, 1.
Also did some speed charge. Also did.
That's fine.
Also did
HV.
All right. Drive whenever you're ready.
Okay, I'm just going to start on the water.
Is that? One more.
Okay, well,